Let's talk about how to find an inverse of a function. We're going to do so algebraically this time. So our first step is to replace f of x with y. After you replace f of x with y, you're going to switch. You also may hear this called interchange. X and y. You're going to solve your new equation for y and replace y with our inverse notation, f inverse of x. If you do not do this last part, you're not completing the problem. And if you need to verify if two functions are inverses, you need to find both f of g of x, so fog, and g composed with f of x, golf. And if they both equal to x, then they are inverses. So you do the composition both ways, and if you get x each time, they're inverses. Okay, we're going to do some composition to prove that they are inverses. I'm going to let f of x be my purple function. I'm going to have g of x be my orange function. And I'm color coding because we're going to be doing some composition. So we need to first find f composed with g of x. But remember that when we do this composition, it means we're plugging g into f. So this really means that we need f of our orange function. Okay. So our f function is 3 all over, I'm going to put in some parentheses, minus 4. And this is where x was. Instead of x minus 4, we're going to plug in the 3 over x plus 4. Because we do not have anything in front of the parentheses that we need to distribute, our next line, we're just going to drop the parentheses. So now what we have is 3 all over 3 over x plus 4 minus 4. We're going to do some order of operations. The plus 4 minus 4 can go away. That gets us 0. So now we have 3 all over 3 over x. Remember, whenever we divide by a fraction, and that's what we're doing right now, we have 3 divided by 3 over x, we get to multiply by the reciprocal of the second fraction, which is a fancy way of saying times the flip of the second fraction. And remember that any fraction, or any whole number, I should say, can be rewritten as a fraction over 1. So when we try to do the multiplication here, 3x all over 3 means the x's or 3's cancel. We're left with x, which means the composition of f composed with g of x equals x. So the first way is good. We need to check the second composition, so the other direction. We need to find g composed with f of x. And that means we're going to plug f into g. So I'm going to write g out. We have 3 over parentheses. Let's try writing it again. Wait. 3 over x So I'm going to put a giant parenthesis. And then we have plus 4. But instead of having x in the bottom, we're going to plug in our f function, which is 3 over x minus 4. Now we can't cancel the 4's right now because the one on the right in orange is big. The one in purple is small and stuck inside a denominator. But what we can do is to rewrite our fraction because we have 3 divided by 3 over x minus 4, and then my plus 4 comes down, which means when we divide by the fraction, we're going to be multiplying by the reciprocal, which means that x minus 4 over 3 shows up. Our 3's cancel because there's one up top and one down below. X minus 4 plus 4, but this time the 4's go away and we get x, which means that g composed with f of x is also x. And if both directions hold true, g and f are inverses.